So the final step is look at the dissociation of ions from a balanced equation. So this is the equation for the reaction of magnesium oxide and hydrochloric acid, which you'll hopefully recognize as being an acid and metal oxide reaction, giving us salt and water. Now next week we'll show you how we can turn this chemical equation into an ionic equation, such as this here. And you'll probably be able to do this already, but all we're doing is we're taking ionic compounds and writing them down in their ionic formulae. So these three here, these are ionic compounds. So we've written these down with the ions. This is the ionic formula for these different substances here. And hopefully you'll recognize that water isn't an ionic compound. It's a covalent substance. So anything that's a covalent substance won't have any charges. So this hasn't got any charges here. But what we want you to do is to practice just taking a balanced equation like this, an ionic equation, and just seeing how we can dissociate the ions. The key thing we're looking for here is anything that's got an AQ state symbol. This tells us that these ions are in aqueous solution and therefore they're going to be dissociated. So anything with an aqueous state symbol or AQ state symbol, these are dissociated ions that are separated in solution. Anything with an S for its state symbol, this tells us that although this is an ionic compound, that these ions are locked together in the lattice. They're not free to move around, they're not dissociated. So we can't actually break up and separate these ones here because the S tells us that it's in an ionic lattice. And with H2O, this isn't an ionic compound, so we can't dissociate that either. So when you're dissociating things from a balanced equation, you're looking for these AQ state symbols, and these are the ionic substances that you can break up or dissociate. Anything with an S, an L, or a G, or anything that's covalent like this, you can't dissociate. So let's have a look at Mg2 plus O2 minus. This is an ionic lattice. It's all of these ions are locked together in the lattice. We can't dissociate this, so we just simply write it out exactly the same as it is in the equation here. In hydrochloric acid, this is an ionic compound. It's got these charges here, and it tells us that these ions are dissolved and dissociated in an aqueous solution. So we can actually dissociate these ions here. Now remember, this big 2 multiplies everything after it here. So it's got 2 moles of hydrogen ions and 2 moles of chloride ions. So we're now going to take this and we're just going to dissociate it into the 2 moles of hydrogen ions, which are now in solution, shown by the AQ state symbol, and the 2 moles of chloride ions. Again, these are dissociated in solution, and the AQ state symbol tells us that. So notice now we've taken this here, this ionic formulae, and we've dissociated now into the separate ions. And the big 2 that we had in front of the HCl there, that applies to the hydrogen ions and the chloride ions. For magnesium chloride, again, it's an ionic compound. It's got these charges in the ions here. And again, it's in an aqueous solution, so we can dissociate this magnesium chloride. And we've got 1 mole of magnesium ions there, and we've got 2 moles of chloride ions. So remember, when we're dissociating, we take the small subscript 2 and we put that in front of the chloride ions to show us now that these chloride ions are separate ions and they're in solution, again shown by the aqueous state symbol. And because water is a covalent substance, we can't dissociate that. We simply write it down as H2O liquid again. So this is kind of just practicing dissociating ions from a balanced equation. It follows the same rules as we've done before, but hopefully now recognizing that we can only dissociate something that's aqueous and in solution. So by the end of this video, hopefully you should be able to explain how atoms become ions and be able to recognize group ions using page 8 in your data book. You should be able to write ionic formulae for ionic compounds. And you should be able to dissociate ions either from a formula or from formulae that are part of a balanced equation.